Hey guys, welcome back to my brand new video. In this video, we're gonna be doing physics back to back. So, chapter 7, sound. Everyone knows this chapter, it's easy. So, today we're gonna go through the important points, important topics under the chapter sound. So, sound waves. Sound is produced when a body vibrates and it reaches us through the vibration of the particles surrounding medium. Thus, the sound requires a medium for its propagation. So guys, basically imagine that this is a scale and it vibrates on top of a table, right? Imagine this is a table and it vibrates and it reaches through the vibration of the particles of the surrounding medium. What is the surrounding medium? The table is the surrounding medium for the sound producing body, that is scale, or you can say vibrating body. Sound requires a medium for its propagation. So this is the medium. Therefore, that is why we can hear the sound of the vibration of the body, that is a scale, right? Then look down. It's written our ears are sensitive only to a limited range of frequencies from 20 hertz to 20,000 hertz. This range of frequency is therefore called as range of audibility. So this is the range of sound in which humans can hear. Humans' ears can hear 20 hertz to 20,000 hertz. And this is known as range of audibility. Then the sound of frequency above 20,000 hertz is called the ultrasonic sound or waves. The sound of frequency below 20 hertz is called infrasonic sound of waves. Both ultrasonic and infrasonic are inaudible to humans, but they both travel in a medium with the speed same as the audible sound. What is the audible sound? 20 hertz to 20,000 hertz. Though it is though this 20,000 hertz, though ultrasonic and infrasonic differs from the audible range of a human ears, but still they both travel in a medium with the speed same as the audible sound. The speed does not change. Okay, it travels with the same speed, but just the thing is we cannot hear because our range is different. Then on the right hand side, these points are very, very important. You have to remember this. Maximum displacement of the particle of the medium on the either side of the mean position is called the amplitude of a wave. So maximum displacement of the particle of the medium on either side of its mean position is called amplitude. Then time taken by particle of the medium to complete its one vibration is called the time period. Then the medium in 1 second, the number of vibrations made by particle of medium in 1 second is called frequency. Then the distance traveled by the wave in one time period of vibration of particle of the medium is called the wavelength. Then distance traveled by the wave in 1 second is called the wave velocity. So these are the most important things which you have to remember. Then I hope you understood. Then we have these formulas which are important. V equals F lambda and F equals 1 by time period, that is T. Then scroll down. This and all not necessary. We have another formula, this one. This is important. Then remember this: light waves, sound waves, the difference between those two. I'll give you some of the points. There are 5, at least remember 4 of them. Better to remember all. So this, they can travel in vacuum, light waves, and sound waves require a material medium for propagation. Light waves, the speed of light waves is very high, 3 into 10 to the power 8 meter per second. Here the speed of sound waves is low, 330 meter per second in air. Then these waves are transverse waves. In air, these waves are longitudinal waves. These are electromagnetic waves. These are mechanical waves. And these 2 points external. Now guys, reflection of sound waves. Here you have to highlight some of the things. That is, the return of the sound wave on striking a surface such as wall, metal sheet, plywood, etc. back in the same medium is called the reflection of sound wave. So imagine this is a wall and the sound hits the wall. It reflects back. Imagine it's in a different angle like this. It reflects back. So the sound, you're lifting your hand, imagine this is you. And you're basically lifting your hand and putting any like speaker thing or something. Yeah, the sound comes here and you can hear like this, right? This is called, I'm just giving an example. So this is called the reflection of sound waves. Then one more thing in the same paragraph you have to underline. That is, the only requirement for the reflection of sound wave is that the size of the reflecting surface must be bigger than the wavelength of the sound wave. This is very important. This point is damn important. So the thing is, if the wall is so like tiny and the waves are like this is not happening, right? There's no reflection of sound taking place because the wavelength is more than the reflecting surface. So it should be like this. just that the reflecting surface should be more than the wavelength, right? That's it. Then everyone knows what is echo, right? Production or generation of an echo. So the sound heard after reflection from a distant obstacle after the original sound has ceased is called an echo. Then conditions for hearing like an echo. By the way, this is very, very important, this formula. This is asked in numericals. Okay. Then here, an echo is heard only if the distance of the sound to reach the person at least 0.1 second after the original sound is heard. Sound to reach the person at least 0.1 second after the original sound is heard. Then, as I said, the formula is important. And so, and this is also very, very important. This can be asked in MCQs. So, to hear an echo distinctly, the reflecting surface in an air should be minimum distance of 17 meters from the listener. Distance is less than 17 meters, the reflecting sound will reach the ears before the original sound dies out, and so no echo will be heard. So the thing is, to hear an echo, you need at least the minimum distance is 17 meters. Imagine you're in an empty room, okay, and you just scream nonsense. You can hear it back because the reflecting surface, what is there, that is the wall, its minimum distance is 17 meters, okay, and therefore there is no object, so you can hear more noise, like louder echo. That is because there is no any other object consuming the sound by you, or any object, any vibrating or any sound producing object which is there inside the room. Then this is important, the note in that, the second one, if the reflector is at a distance less than 17 meters, the original sound just mixes up with reflected sound. Therefore, no what is it? There is no echo heard clearly. And if there are repeated reflections at the reflecting surface, the sound gets prolonged. This effect is known as this effect is known as reverberation. Okay, reverberation. And then, so I hope you understood. The reflector is at a distance less than 17 meters. Sorry, the original sound just mixes up with the reflected sound. There are repeated reflections at the reflecting surface. The sound gets prolonged. This effect is known as reverberation, which can easily be experienced in tombs like Taj Mahal, Sikandra, etc. So yeah, now then we'll go down. It's written over here, the minimum distance between the source of sound and the reflector in the air must be 17 meters, as I told you. It is different in the different medium depending on the speed of sound in that medium. and there's example given that you have to read. Then we'll go down, and this is the formula, which is also important, can be asked for your numericals. So this is V equals 2d by t meter per second. Means V is the speed of sound, and d is the distance traveled by the sound, and t is again time interval. So 2d by t equals 2d by t meter per second equals V. Okay. Then uses of echo, you should learn. They'll ask. So just highlight some of them. They can travel undeviated through a long distance. They can be confined to a narrow beam. They are not easily absorbed by in a medium. Okay. So this is also important. Sonar. What is sonar? Sound navigation and ranging. Then next page. This is also not so important. And yeah, radar is important. Remember this. Radio detection and ranging. Yeah, this one. Then so both sonar and radar, the transmitter and receiver are placed close to each other. They are shown separated just for clarity. Okay. So guys, next section is kind of interesting. It's all about natural damped forced and resonance vibrations. So natural vibrations, just the definitions are very important. So highlight those. The periodic, this is a natural vibration. The periodic vibrations of the body in absence of any external force on it are called the natural or free vibrations. Okay, just memorize those, or you can read it again and again so you can understand better. Then we have the damped vibration. That is also very important. The periodic vibrations of a body of decreasing amplitude in presence of resistive force are called damped force. Resistive force means external force. So basically something like this. It decreasing amplitude. So this is an amplitude, means displacement of a wave, so it decreases. Then examples are given, just go through that. And there are differences between natural vibration and damped vibration. Again, just go through that. And here forced vibration is important. Vibration of a body which takes place under the influence of external periodic force acting on it are called forced vibrations. Okay, I hope you understood till here. Then we'll go down. Means the next page we have resonance. Resonance is actually the most important thing in this chapter, because most of the questions come from here, like based on it. Not most, you can say, yeah, almost. And you have even the numericals coming up with this. So we'll just go through this. And resonance, so it is a special case of forced vibration. This is the first point you have to remember. Okay, one, externally applied periodic force. When the frequency of externally applied periodic force on the body is equal to its natural frequency. This is second point. The body readily begins to vibrate with an increased amplitude. This is third point. These 3 points are very important for this definition. Resonance. So resonance is a special case of forced vibration. That is the first point you have to write. It's already written here, special case of forced vibration. So don't forget these 3 points. If you forget one, there's chances of losing full marks for this definition. So then we'll go to the next page. Conditions are also important. Just go through it, and these are some of the example experiments which they did for us. Just also go through it. It's fun. And we'll go to the characteristics of sound and their subjective and objective nature. So loudness, pitch, quality. Loudness and intensity means quality. Loudness is a characteristic by virtue of which a loud sound can be distinguished from a faint one, both having the same pitch and quality. Right? So then we'll go down. Loudness of the sound depends on the amplitude of the wave. That is important. Then go down. Factors affecting the loudness of the sound. I couldn't find it. So factors affecting the loudness of the sound, guys. So just highlight what I am doing. Loudness is proportional to the square of the amplitude. Loudness varies inversely as a square of the distance from the source. Loudness depends on the surface area of the vibrating body. Then one more. Okay, never mind. Yeah, 4 we have over here. Loudness depends on the density of the medium, and loudness depends on the presence of the resonant bodies. Okay, so then we'll go down. This formula, you have to just go through it. Relationship between loudness and intensity. And just go down. Pitch is also there. Pitch is that characteristic. I hope it's there. I don't know if it is there. Timbre is there. Timbre means quality of the sound. We'll just go through timbre of the sound. Quality of the sound is the characteristics which is distinguished by two sounds of the same loudness, same pitch, but emitted by two different instruments. So same loudness, same pitch, but these sounds which are emitted are from two different instruments. Okay. Then we'll go down. Then I guess we finish this part. Okay, we have one more thing, that is the characteristic and the loudness, that is this one. Okay, the characteristic of loudness, pitch, and timbre and quality. Factor: loudness factor is amplitude, pitch factor is frequency, timbre or quality factor is waveform. Then we finish with this. The next point. Okay, we finished, I guess, and this is the one which is after important. I'll just mark it for you. So first thing is, it is a regular, smooth, pleasant to the ears. It is produced by the vibrations which are periodic. The sound level is low, the waveform is regular. Then it is harsh. Okay, so it is harsh, discordant, and unpleasant to ears. It is produced by an irregular succession of disturbances. The sound level is high, about 120 decibel. The waveform is irregular. By the way, RCB Stadium, Chinnaswamy Stadium, the decibel is 127. So that is a noise, you can say, because it is above 127. So that's it. We finished with the chapter. And okay, sorry. And yeah, we finished almost like how many chapters? 4? I don't know. 4. Yeah, I guess 4. So I'll see you in the next video. Then take care, everyone. I hope you finished your exams, so enjoy your holidays. So till then, meet you soon. See you then. Take care, everyone. Stay safe.